Testing, 1, 2, 3. Cool. We in there. So, I had a lot of fun working on this web app. Oh. I might have broken it already because I rendered before it was finished loading. It's not the most stable thing in the world. Yeah, I did break it. Okay. But anyway, I think I got to put some of the work on this on hold and make sure I make the lesson really good. I think it'll be a lot easier if I just go through and write notes for everything that I plan to go through. And then I can just go through the notes section by section, hopefully. That'd make it really easy to follow. I had to run so much stuff for the website. It's gonna be kind of annoying to have to bring it up again. Because it's mostly the Docker image and then the web dev thing. It's not so bad. I should probably take a note of it somewhere. Hi, Aquabeam. I'm nervous. What do I do? It's good that I finally made an announcement about it. Because now I actually have to make it, like, good. Otherwise I would have kept probably procrastinating. I do have some pretty good experience speaking. The hardest thing about it is going to be not working on the web app. Because I like it. And if I could, I really wanted to get some way to have like numbers that update with your cursor position. So that I could like, just like you could move it at an angle and it could show you a live update of the sine or cosine or whatever. That'd be really cool. But I have to do that later. Because I gotta get these notes written out. Why it's a live stream? Well, why wouldn't it be? As opposed to a YouTube video, you mean? And part of that is that in general, I have this idea that Manim should be something that you can use without a ton of preparation, so it shouldn't require just being theatrical. I can't pronounce that name, but thanks for following. No problem, but I do have this idea that Manim should be something that you can use effectively without doing a lot of preparation. Because that's the only way you could use it in an environment like a classroom. Well, I guess you could still pre-prepare something for a classroom, but it should be the case that, like, if you were learning something about geometry or whatever, there should be a few basic functions that allow you to just, like, see a circle if you want to see one, or see angle bisectors if you want to see, or whatever. And so I want to get into the habit of using it without a lot of preparation. That explains how Manim works for future coders. What do you mean by coders? Do you mean like other people who are trying to develop it? or other people are trying to use it to create videos. Because it would be different depending on the audience. Okay, let's open this up. And then I go on to open up the notes. Which I don't even know if they're here. Dev docs. Maybe one day. I think the notes that I wrote aren't even here. Which isn't a big deal because they weren't very good. Process. Been creating animation software, and the process would be easier if I didn't have to pour through so much of Manim to get an idea to see where it starts. Okay, so information about animation more generally. I'm probably not the best person to teach that. Like, I can teach it in a specific case of Manim. Oh, here it is. But as for general stuff, there'll probably just be a lot better sources for that. Oh man, I didn't expect so many people to come. I'm literally just preparing my notes now. I joked to a few of the people who were here earlier that 6419 that if you watched me do all the preparation for this, I don't know if you'd have to take the lesson. You might be able to pick it up just from watching me work on it. But of course the lesson will be like 45 minutes to an hour. And I've been working on this for a while, so of course there's that major difference. Okay, so these old notes aren't that organized. So I'm going to try to get these more tailored to what I'm going to do during the lesson. Starting with, and I can just do this section by section probably. Well, no, I'd rather, I'm going to have the concepts in these notes be laid out according to what I want to teach, and then the animations will be secondary to that. So the first thing on the OpenGL pipeline, which is actually already a section for that here, I'm going to go through all of the phases that I animated. I'm giving away spoilers, but anyway, and that is way too big. I'm going to go over, let me just list out all of these. The vertex shader. Daryl Golden, what's going on? Actually be vertices before that. Vertex shader should be the next part of this. Is Manim future-proof with MacBooks considering the deprecation of OpenGL? That's a good question, to be honest. Yeah, I don't know. I don't know how suddenly Apple would just get rid of OpenGL. But I think what'll probably happen is it'll become like less maintained over time. Or something like that. I think it would be really beneficial to move Manim over to WGPU. Which is basically the thing to succeed OpenGL. Why in the world? I wanted another window. But that'll probably take a while, to be fair. It might be kind of slow. But basically, this is the successor to that. Linux elitism gang. Linux is really good for development. There's no doubt about that. Like, I'm not totally sure that I would be able to do development on a Windows machine. I could probably do it with a Mac. But I'd just be annoyed. I'd be annoyed for a lot of the time. Shiny OS. It is quite shiny. The thing about that stupid thing, though, at least with the new chips, is that you can't install NumPy that easily. You have to do some crazy thing to install NumPy, at least last I checked. And I'm scared I have to double check everything I say so I don't spread misinformation. Should we install NumPy? Oh, it's on the M1 chip. Let me just put M1 here. I guess with this specific version there were problems. Oh yeah, there are a few, like this person can't do it. Maybe this is a fix. Oh, and you have it running in one. Okay. Then maybe that's gotten better. So let's see how Apple can decide we don't want to borrow the OpenGL. Now we have to worry about structure. Yeah. Yeah, that's true. There are these trade-offs that are pretty hard to get right because like it's not that great they can do that, but it is helpful that it is sometimes helpful to have this power to push things forward, like centralized. Like for example, this is pretty much the only good example I can think of for this though, is that Google pushed this effort to, if a website isn't using SSL, it'll like yell at you. It'll say, like, we're just not going to let you go to this website, especially if you use a .dev subdomain. And this annoyed people a lot because there were people who were using .dev subdomains for testing, development. And Google just forced it to use HTTPS. And a lot of people, when they were testing, they didn't use HTTPS. And now it basically just screwed them over. But I guess there's more secure TLDs for what that's worth. Okay. I'm just going to take really short notes on these. List of data points with of which my Gingy. Thanks for following. We looked into Metal, which is good for Apple Silicon, but Swift comes with a package. Yeah. That's pretty annoying. I think it's going to support WebGPU or whatever. And if I understand right, WebGPU isn't required to run on the web. I think. Yeah, the WebGPU API. I hope we can actually read this. Uh-oh. My browser's freezing. Anyway, the Web GPU API targets native and web. Each of which has the same attributes. Have the same attributes. Have you considered BGFX? What is that? List of data points. Vertex shader. In the vertices, outputs positional data. We'll have to do another painful migration. Yeah, I mean, at this point, I've written a lot of renderers for Manim. And what's one more, to be honest? At this point, I just written a bunch of them. Convert vertex positions into a few different primitives, and you're just rewriting the shaders. Pretty much it's like rewriting and accommodating the new API. But as far as like what the vertex shader does, what the fragment shader does, that stuff will probably be the same regardless of what API you use. Convert each primitive into fragments. I should probably go over the definition effect. Well, I don't really have a definition of these, like pixel sized pieces. Blake 4096, what's going on? How have you been? Problem with our migration of the polluted codebase with 3B1 brown code. Yeah. Polluted. A big problem with it is that so much of the API doesn't make that much sense. And so we have to go back and like fix that. It's kind of annoying to do in hindsight. I like to go back and fix the stuff that could have been done better the first time. Determine colors and opacity. I'll just say color. No, I should say and opacity. For each fragment. Determine colors for each pixel on the screen. Okay, when I see config, yeah. Just use KWRX. Now, I'm in a difficult position because everyone likes Grant a lot. And he's just a good person. He's a really nice person. But I argued with him to fix some of these design choices kind of a lot. And he ignored me. And, you know, if he didn't, we wouldn't be having this problem as bad. Anyway. Into frame a frame buffer. Maybe it's the frame buffer. Shade. Well, I mean, it's cut off a lot of my lifespan. But what are you gonna do? You gotta fix it somehow. And rendered to the screen. And my understanding that writing to the frame buffer is one-to-one with rendering to the screen. I can't tell. Oh, is that a light or something? I don't know what that emoji is. Let's see. Primitives generation. I feel like I should have a vocabulary section where I just go over a bunch of the terms. It's good I did this fairly early on so that I'll have time to like do dry runs of this. Well, this didn't format, right? How do you make this bigger? I wish I knew Markdown. Okay, I guess that's fine. Smiling face with tear. Oh. For future reference. What? Just come to the lesson. Even better. Can I do this? No, then it's on the same line. No problem if you can't, though. Like, I realize people have other commitments and stuff sometimes. Rave Lex 1. Thanks for the follow. I've got to fix that zombie thing sometime, too. The vertex shader transforms. It reads in vertices and outputs. Positional data. That's true. Convert vertex positions into one of a few different primitives. True. Convert each primitive into fragments or pixel stage parts. Different color and opacity for each fragment. Different colors for each pixel. Why would I say on the screen? For each pixel by combining fragments. What is Hugo? Fragment data. Let's render frame buffer and render to screen. Great. Okay, and this is a better walkthrough than that one. Static site generator. Oh no, I didn't set that up. I'm using something called grip. And that, it's a really big header. That's probably a little better. Yeah, and already here I was starting to get started with a vocabulary section. And I don't want to make this feel like high school. But having the vocabulary to describe these things makes the understanding a lot better. However, I'm not going to fill these out right now. Well, the shader one's pretty straightforward, a program that runs on a GPU. I might as well copy this. Do there. I should just write out all of these. Primitive. Like the definition of shader. Thanks. I came up with it all by myself. Only probably not. I don't remember where I came up with that. Or how I learned it. So I don't have a good definition for frame buffer yet. I'll leave that blank right now. Great. And this part goes with the OpenGL pipeline animation, obviously. But I won't put that in the notes. Okay. So I'll have that. This code isn't... I won't have to like go over any of this code. Have GitHub Copilot write a backend. That'd be funny. If computers got to where they could like do things that complex. Don't think it'd be that successful right now though. Okay, so the half screen triangle. Uh-oh. Oh, there we go. So this code I'll have to go over. Luckily, it's pretty straightforward. Maybe I could even save some of these lines. Is that any more confusing? Probably not. Great, so I'll just... I might not even need the version string. Well, I guess I did. Okay. The code module should work in OpenGL. Great. Thanks. It's kind of too late. Like, I don't know if I want to move it over. But it'll be useful for later on. I feel like now that there's people watching, they'll just figure out all the lesson stuff from watching me work on the lesson. And then they won't watch it. Which I guess the purpose would still be... I would still, like, complete the purpose of the lesson. Okay, let me see if I can... Alright, so this is an example... Shader and Manim. Like rendering triangle with OpenGL. It's using Manim to render the triangle with OpenGL. Great, and then I'll just pretty much copy this code verbatim. Yeah. Shader equals whatever, all of this. It's pretty much what's already there. Okay, this will definitely be worth walking through in sort of an abstract sense, just to make sure everyone understands it. Like for 1001, it might actually be more clear. It would lead into homogeneous coordinates really nicely if I explicitly wrote out vec4 here. Actually, it says vec4 position, so that's fine. Actually, no, I think I like the idea better of making this take in three-dimensional data. Oh, you're from the Discord. Nice. It's a good Discord. Okay, so I'm going to try to pass in three-dimensional data to the shader. Make this a vec3. Maybe that would work. Of course it didn't. But I do. Tutorial 240. Point. NDC location. Why did I need that? Oh, I didn't. So we want point. I'll have to take out this one. Then I won't have to do this. Okay, see if that works any better. Great. And I'll actually copy the shader back over. Okay, and now if it just looking at this, there's a few things to walk through. Honestly, the best way to approach this would be to just walk through this, map each part of the pipeline onto this, at least to the extent I can. That's sort of what I was doing. Let's walk through the shader, starting with the vertex shader. I shouldn't start with the vertex shader, start with the vertices. Starting with the... I'm running out of screen space. I wonder how small this could get where... I don't mind that much if it's hard for me to see it. But I do mind if the stream can't see it that well. Even though I realize some people just have this in the background. Okay. Vertices. R Markdown over LaTeX. I'm not actually sure what R Markdown is. I'm using regular Markdown right now. LaTeX would probably be better, to be honest, but I just don't have any LaTeX set up right now. So I'm just going for something that's readily available. Okay, so we start with the vertices. Then right here, actually in the shader, Alem BCKE, thanks so much for the follow. Really appreciate it. And Yoshinin? 69, thanks as well. Okay. So the vertices is basically here. So start with that. These lines specify a format of data passed. The data format, each vertex. The vertices in this shader have only a position. Single attribute specifying their position. Position. Yeah, I think that's a decent enough explanation. And this will lead pretty naturally into the realization that normalized device coordinates map a 2x2x2 cube to the screen. And that is not updating. Why? Oh, I must have broken it when I moved the, when I changed from 3-dimensional to, from 4-dimensional to 3-dimensional. Did I? Attributes at position at indexed at data. Point. I think I want not +1 now? Maybe. Okay, there we go. Specifying their position. Okay. And so this way you can tell pretty immediately the way that these correspond to the screen. I think. Yeah. Cool. So now we get the vertex shader. The vertices, and I'll copy the vertex shader. This is our Python. Great. This vertex shader simply outputs the same point passed to it. So this isn't the same point anymore. Same point passed to it. Outputs, it's not the same one anymore. The homogeneous equivalent of the point that was passed to it. Homogeneous. It's definitely something that'll have to go in the vocabulary. Probably right next to normalized device coordinates. Thing is, I don't have a good definition of homogeneous coordinates other than that they're 4-dimensional. Insert brief elaboration on homogeneous coordinates. I guess that just doesn't appear in Markdown. I didn't know that. Okay. Then I'll just talk about the primitives. After the output, after the vertex shader. Okay, so I went over and I said that the vertex shader outputs positional data. The vertices shader runs and sees an HTML tag. Gotcha. Oh, that's weird. I guess that's why the insert is different color. Data outputs is used to draw, say, triangle or triangle primitives. That's actually good. Triangle's the most common type of primitive. These triangles are. I'll just put a new line there to emphasize that it's a single step. These triangles are rasterized into fragments, which are then colored by the fragment shader. Let me just copy the smaller version of the fragment shader code. It's interesting that Twitch typeset that as an arrow. Or maybe it's not Twitch, maybe it's just Streamlabs OBS or whatever. I think it's Twitch, okay. The fragments are then colored by the fragment shader. Then I have the fragment shader. This fragment shader colors each fragment red, filling the channels of each fragment with 0001. As a vector passed to the frag color variable. Yeah, that's actually perfect. After the fragments. I actually don't know if it's after. I can say the fragments output the fragment data from the fragment shader. It's then blended in order to determine the color of each pixel. Fragment data from the fragment shader is then blended in order to determine the color of each pixel and written to the frame buffer. Okay. So here we have we have some vocabulary. We have the OpenGL pipeline. For the example using Manim to render OpenGL. Let's just go through the attributes. The vertex shader. Primitive generation, rasterization, fragment shader. And then it just goes over the rest of the steps. Okay. That looks good. So if you see that, at this point I would have skipped over the homogeneous coordinates, so I'd have to mention why this is a vec4. And probably why this is a vec4. Now that's kind of more self-explanatory. Okay, so then I have to start section homogeneous coordinates. And honestly, I don't know if I can give like a clear explanation of homogeneous coordinates right now. I know how they're used, but I don't have a good idea of like how to explain them in a way that makes them sound useful. Currently, they sort of seem like just more work than Cartesian coordinates. Parallel lines in Euclidean space are said to intersect at a point at infinity corresponding to their common direction. Given a point xy on the Euclidean plane for any non-zero real number z, the triple xz, yz, z is a set of homogeneous coordinates for the point. This makes sense. This is the result of an equivalence relationship in order to focus on directions rather than vectors. Maybe. I don't know. I mean, that sounds like something that could be useful. I mean, yeah, they do allow you to encode translations within transformation matrices, which is extremely useful. So maybe that's like exclusively why they're used? That could be the case. Okay, but I've gone through this. I have to go through the homogeneous coordinates and then maybe... Yeah, I don't think I have to talk about blending right now. I can probably just say that this is pretty much just opacity. Then I'll go on to the projection. Do the fonts look bad? Fonts where? I know there are some jank fonts on my browser. So there's that. But yeah, I guess I have to know which fonts you're talking about. Alright. Since generally think of scenes in terms of... Oh, I'd have to go over normalized device coordinates too. Because homogeneous coordinates bring you to the normalized device coordinates. Although these are really easy to explain. I can pretty much just copy what I wrote before. Yeah, I don't have to say too much about those. I think it's in terms of... I should probably say that these are sometimes called indices. No, I'll just say the whole thing out. We'll need a way to convert points in our preferred coordinate space to their equivalents in normalized device coordinates. Okay, so hopefully this will show that. Since we'll have a... Darn, I can't move this. have a triangle here. And hopefully... Yeah, and you can see that it maps it directly into Manim space. Oh, that's not supposed to happen. Okay, because I'll have to disable that. Did you see that this maps it into Manim space? No, these device coordinates. Now I don't want to just say use a projection matrix, but I want to like build up to it and say, why did I just say points in the x direction? Have to be mapped from... How would I walk through that? How would I explain this in words? Well, I could say this effectively means at each point in... Nah, forget it. I'll just say this is done with the projection matrix. This is done by transforming with a projection matrix. A projection matrix. Coordinates from what is called... Actually, I don't know if I could talk about the spaces yet. Really, it moves it from camera space into clip space. But we haven't talked about cameras yet. So I guess I can't say that yet. I'll just say what's called a projection matrix. But this makes me want even more to not just say use a matrix. I really want to like allude to this idea that it has to be scaled in each direction. Should say something like since this requires mapping points in your preferred coordinate space into a B 2 by 2 by 2 cube at the origin. The x coordinates and y coordinates have to be scaled by factors of, and what would the scale factor be? 2 divided by like x, where x is the width of your coordinate space. Divided by y, and I should include this for z. The x, y, and z coordinates will be scaled by those factors respectively. Let me see what this looks like. Now this sounds a lot more like it's something that should be done with the matrix. Although there isn't a linear combination here. that's true. But this would be a good place to say that since the Manim coordinate space is like 14 by 8 or whatever, that we'd want to use a shader, or we'd want to use a matrix that has 14 and 8 written into it. Use inline LaTeX for math. Well, let's hope so. I don't know how good this is. Yeah. This is like a fairly bare bones markdown editor from what I know. So I guess it doesn't support that. It's too bad I didn't write down this matrix anywhere. I don't even know what this matrix is. Orthographic projection. I should know what it is. Yeah, it's doing it. 2 divided by height, 2 divided by width. Don't know what's happening in the z direction to be... Oh, I know what's happening in the z direction. Yeah, I know it's happening in the z direction, but... honestly, maybe I should just type out a projection matrix that doesn't have a concept of a camera and use that one instead. Let me try that. Because the fact that this is compensating for the existence of the camera is going to make it a little more confusing. And depth? I guess I'll make that 10. I can dig up an example with Pandoc. No, it's fine right now, but that would probably be helpful later, though. If you could like tell me in Discord. Oh, well, I'm not sure if you're in the Discord. Oh yeah, you said you learned about this from Discord. So yeah, if you like message me. And this is a concept of a near and far plane too. Or I guess the near plane would technically be negative, whatever the depth is, so like negative 10. Okay, and now I can just add 0, 0, 0 here and 1. Far minus near. Okay, so that's gonna give 20. Okay, so maybe this will work. And the transformation I want to do is I want to take these points and not put a false there. Take these points, which are row vectors, transpose them, multiply them by this, thanks. So transpose them, multiply them this, now they're column vectors, and transpose them again. And maybe that'll work. Or maybe it won't. Oh, I guess is this live updating? I can't tell if it's working or not because of the distortion. Great, it still works. And that's going to be a lot easier to understand than... Like, it's better just because you don't have to look at this word, orthographic projection matrix. Like, what does orthographic mean? So I'd much rather just write out this simple matrix. Cool. Maybe I don't even need this near and far business, since this is just a depth. So I'll just say we can assume that we want a world space that's some width, height, and depth. And whatever it is, this is how we transform it. Yeah, I'll do that. Okay, so let me see how this reads. Since we generally don't think of scenes in terms of normalized device coordinates, we need a way to convert points from our preferred coordinate space to their equivalents in normalized device coordinates. Kind of don't like that this is repeated twice, but that's probably fine. Since this requires mapping points in your preferred coordinate space into the 2x2x2 cube centered at the origin, the x, y, and z coordinates will have to be scaled by factors of 2 divided by x, 2 divided by y, and 2 divided by z, respectively. This is done by transforming them with what's called a projection matrix. Okay, and I think that's a really good visualization of that, together with the graphic. I should just say, like, W, H, and D here to make it clearer. Where W, H, and D represent... Actually, there's a lot that I'm assuming here. I'm assuming that you want a coordinate space that's centered at the origin for one thing. Sometimes you might not want that. So their equivalents in normalized device coordinates, which requires mapping points in your preferred coordinate space to this cube centered at the origin. Although, yeah, okay. The equivalents in normalized device coordinates. I guess all of this is true. You'll still have to do these scales no matter what. They represent the width, height, and depth of your preferred coordinate space, respectively. What I should do is, instead of saying your preferred, I guess I only said it twice. I should say world space. Thanks. I'll look into that in a bit. I guess after this. To equivalents in normalized device coordinates. Wait, is normalized device coordinates what I'm looking for here? Yeah, I think it is. Yeah, it is. It's normalized device coordinates, but it's really normalized device homogeneous coordinates. But whatever. Where W, H, and D represent the width, height, and depth of your preferred coordinate space respectively. This is done by transforming them with what's called a projection matrix. Okay, so let me not call this mat. I'll call this projection. And here. And do the same thing. Okay, so that should be... So that's great. And that visualizes exactly what that does pretty much. And since we've already done matrix transformations at this point, this is a really good segue into model matrices. Which, if you're not using model matrices, you've got to start using model matrices. And I crashed Manim, or something like that. There we go. And if you're using Cairo, you're not using model matrices. Okay, so this should... Det Nug, thanks so much. Why not just make .shift use model matrices by default? So there's some complexity there. And the reason for that is that if you transform a mobject using its model matrix, well, two things. Well, the most pressing thing is you don't change its points, which means that things like get center, get left, get right, they won't work because all the points are being mapped by the model matrix. Also, you learned what model matrices are just from watching me like put this together. So that's funny. Okay. How would I introduce this? I'd say like I'll just say like matrices are a convenient way to transform meshes. I don't know if I've used the word mesh. I definitely should at some point define mesh. I should also world space, camera space, flip space, all of these. I'll have to define. Those who don't work, model matrices don't sound so tempting to use for general purpose stuff. So it isn't that they don't work. It's that Manim wasn't designed with them in mind. And so they won't work in Manim. If we'd started using them from the beginning, they'd be really convenient. But I guess the technical answer is that get left, get right, etc. will return answers in model space, when usually what you want is in world space. Which world space is just like you take every point and multiply by the model matrix. It's just like this. Basic model space is just the points. World space is you multiply by the model matrix. Camera space is you multiply by the view matrix. And clip space is you multiply by the projection matrix. So it could be done, we just have to, like, make sure it doesn't break random stuff. To perform any affine transformation on attribute data. On I should just say on attributes. That's probably fine. Assuming I actually know what an affine transformation is. Affine transformation is one of those things, like video game, that you've never looked up a definition for it. You just like figured out what it is eventually. I guess this is probably fine. Lines and parallelism, but not necessarily distances and angles. You definitely want to talk about, you definitely don't want to talk about an automorphism of an affine space, or a function which maps an affine space onto itself while preserving both the dimension of any affine subspaces and the ratios of the lengths of parallel line segments. Yeah, I'll just take this. There's so many extra words in this. After that first sentence, yeah. Imagine, like, you know, there's always that one person in your linear algebra class or whatever, where everyone's talking about affine transformations, and one person calls them affinities, and you're like, okay. You're like, anyway, I'm gonna multiply by this matrix. And he's like, oh, you're going to map an affine space onto itself while preserving the dimension and the... You're like, all right. Preserves lines and parallelism, but not necessarily distance angle. I think this is fine. I'll just keep this. Any affine transformation on... I really want to use the word meshes here, but I haven't used it yet. I guess I used it in this variable name. Maybe I should just, after the shader stuff... Actually, I used it even in this variable name. The vertices in the shader have a single attribute specifying their position. I don't even have that great of a definition for mesh. A mesh is like your conception of an object. But from OpenGL's perspective, it's just a list of data like this. The data format for each vertex. Maybe I should just go over the last line of that. Where is it? Here. To the frame, just at the end here. I'll say a mesh refers to an object by OpenGL. I don't know if this is a technical term or anything. I just say for the purposes of this lesson. I don't know for sure. Like if I just search up a mesh, is that a... If I could give me something about wire, yeah. This is a Quora question. A mesh represents a single drawable entity. That's a good definition. That's fine. So I won't say represents, I'll say refers to. I'll say in OpenGL. I should also put this in the vocabulary. Maybe I don't even need this to be here. I can just put it in the vocabulary. Great, now I can come down here. Or any affine transformation on meshes. Perfect. So then this we can use this to see the way that what translating does. And I can't put it back exactly. You see that translation doesn't seem to do anything. Z rotation, X rotation, and it disappeared. Y rotation, etc. Coolio. Wait. Okay. Let me see what this code is doing. Model. So I have it in identity by default. Oh, it's actually taking in both a model and projection matrix. It would actually be, I think it'd probably be helpful to just walk through all of this code. Since it's pretty straightforward. And all it's doing is like updating these. This translation, rotation, and scale. And then on each frame, it's just the model matrix to the translation, rotation, and scale. We need to perform any affine transformation on matrices. If we were to use non-homogeneous, I'll say traditional. Traditional 3x3 transformation. Well, I should explain what a model matrix is. If we associate each mesh with a transformation matrix, we can use linear algebra each mesh with a transformation matrix and pass it and transform it with that matrix before rendering. We can use linear algebra to perform any affine transformation on our meshes. If we were use a traditional 3x3 transformation matrix as a model matrix, it wouldn't be possible to encode translations. However, homogeneous transformation matrices to encode translations, rotations, scales, shears, technically. Translations, rotations, scales, shears. And I said translations twice. Okay, it'd probably be useful to walk through that code. Especially to sort of appreciate just how much you can do with a model, with a mesh, without changing its points. Because that's pretty cool. Powerful tool to transform any mesh using the same method. I would actually love if Manim ran with like model matrices for scale and translation and things like that. That would be really convenient. Submit this for someone. Well, it's not a video. I want to lean a lot more toward the goal of using Manim for like demonstrations or like live presentations rather than videos. Or at least I want to make that part really easy. Maybe I should just go over the vertex shaders. That's where everything's happening. Submit the VOD. Imagine how annoyed someone would be if my thing won over something that was edited. I would be mad. Okay. So this vertex shader takes a projection and model matrix and it fills a niche. Yeah. I think Manim reveals like it has a very good capability to just churn out a ton of very narrowly targeted interactions, I guess the word would be. Like it'd be useful to have just like one page of visualization of like sine, cosine, tangent, and then the next one a visualization of the inverse trigonometric functions. Then the next thing, a visualization of like the unit circle or something like that, so that you can see them. You can get a feel for what they're describing very quickly. And then there isn't much value added in like animating text and things like that. Unless it's like an equation, then they can get some value from that. Transform each point prior to returning them. I guess I haven't even talked about vertices or attributes, uniforms, and varyings yet. I'll have to put that on a to-do or something. Right, it's so sexy, it makes people spend 20 seconds. Yeah, I've seen a fair amount of that. It does look really nice. Transform each point prior to outputting them. I think that's all I needed to say, really. Traditional. Great. So what's after that? After that, I go straight to the view visualization, which I think is okay. At the view visualization, that's probably when I want to talk more about attributes, varyings, and things like that. Or actually, right after the barycentric interpolation, then I think I could redo the view visualization with a colored rectangle. And I think that would, like, demonstrate that really nicely. I'm so proud of the view visualization. I put so much work into it. And stuff. Although it does need a cache to get going. Okay, so that's model matrices. I guess I'll just call this, I'll do this singular view matrix. The way I'd want to talk through this and motivate it is really different from the way I'd want to write it down in notes. Because if I was trying to motivate it, I would say, okay, so imagine we wanted to transform this object in response to a camera being moved. Now, if the camera moved in the positive x direction, the model would move in the negative x direction. Now, if the camera rotated around the positive x-axis, the model would rotate around the negative x-axis. Oh. And I should have done the z-axis. And that's how I'd like motivate that. But since I'm not doing that, I could just save that for the lesson. Or if I do a few dry runs, which I probably will. The view matrix encodes the... The position of our world's camera. Since any transformation, any affine transformation to the camera will be reflected. I don't know if be reflected is the right word. It'll appear as the opposite transformation. Any affine transformation to the camera is equivalent to the opposite transformation on each object in the scene. The view matrix is the inverse of the camera's model matrix. And that's really pretty much all there is to say about the view matrix. I think what I'd probably have to go back and do is revisit the projection matrix. The view matrix is just such a powerful concept that once you understand that, you can do like pretty neat 3D scenes like that, like this. Yeah. So I'd say the projection matrix revisited. I should go over a bit about how projection matrices can do more advanced things than just scaling. So when we went over projection matrices before, we used them to scale objects. However, it can be, say, more complex. Should the word be complicated here? I generally consider complicated to be a bad thing these days. I'll say complex. Can be used to incorporate perspective in a scene. And honestly, for this section, I'd be much more comfortable just linking this page, not this page. Well, maybe this page. Sophisticated. I like it. Perfect. Yeah, but I don't know if it's... Maybe it's worth me going over this a little bit. I'll probably, honestly, at this point, I'll probably just open up this webpage. It's just so good. Like, this webpage visualizes so much I was describing in a really neat way. There's not really any point in redoing it. Okay. But I will have to go over orthographic and perspective. You say... is a lot of theory one could go into regarding this. But for the purposes of this lesson, just know that orthographic projection matrices do not... Wish I had this in my computer vision class. Thanks. Yeah. I consider myself a decent teacher, if I do say so myself. Okay, orthographic projection matrices do not have a concept of perspective, while perspective projection matrices do. It'd be pretty useful, I think, to have an example of something using an orthographic and a perspective matrix. I think. You probably would. Maybe. I don't know. I think the idea that I could almost just draw it, since you know that parallel lines with an orthographic transform will remain parallel. But parallel lines in a perspective transform will intersect at the horizon if they're moving away from you. Professor. I feel like I would hate being a professor. I don't like the research. I like teaching though. But I feel like I would hate doing the research. I could be a teaching professor. Okay. Perspective projection matrices do. Great, I think that's all I really needed to say. And from there, barycentric interpolation. I wonder if anyone would actually ask this question, but I'll end up mentioning that the vertex shader runs for every vertex, but the fragment shader runs for every fragment. So where does the fragment shader get the extra inputs? Since obviously there's more fragments than vertices. And hopefully nobody will ask that question. And I'll just put it off until here. Where is the inputs to each fragment? The inputs to the fragment shader. Each fragment. Do you cover the surface shaders? No. Grant's shaders are probably... I probably couldn't teach those very well, even if I wanted to. It's pretty likely... Well, actually, I know for a fact. He basically just did them all by hand, so there's not a lot of theory to learn. Unless I found a way to, like, factor it out from what he did end up doing. But it wouldn't be something you could easily apply to another project. There's the inputs to the fragment shader. for each fragment by interpolating in each interpolating vertices or vertex data. The fragment shader for each fragment by interpolating vertex data. Maybe I want to say interpolating data from the vertices of the primitive of which that fragment is a part. That's a awkward sentence. OpenGL determines the inputs to the fragment shader for each fragment by interpolating data from the vertices of the primitive of what. Yeah, I'm not gonna write that. That's insane. By interpolating vertex data. The vertices I don't even know how I'd say this. Maybe I'll just go to the book. Let's see what this says. I wonder if this mentions barycentric interpolation. Blah, 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 blah. The rasterization requires for OpenGL to generate fragments inside the triangle, but also to interpolate values on the figure. One of the legitimate questions we solved is then, if I have a triangle, each summit vertex having, for example, a different color, what is the color of a fragment P inside the triangle? The answer is barycentric interpolation as illustrated. I think that's pretty much what I wrote. If I have a triangle, what's the color of a fragment inside the triangle? Inputs to the vertex shader for each fragment by interpolating vertex data. Each field of the triangle that the, let's say that a given fragment builds up comprises each field, let's say each vertex, or the vertex data of the triangle that a given fragment comprises is interpolated barycentrically. There's no way that's a word. OpenGL uses barycentric interpolation to, I don't know, determine these inputs. That's probably fine. OpenGL determines the inputs to the fragment shader for each fragment by interpolating vertex data. OpenGL uses barycentric interpolation to determine these values. I think that's fine. I could write out what barycentric interpolation is. Actually, I probably should. But why would I do that when this picture is so good? If it appears. You can just read off what barycentric interpolation is. It's beautiful. But I should probably write something about lambda i's and AIs and things like that. I wasn't trying to switch that there. Yeah, I don't know. I should probably write down the formula. I don't know if I can just copy this. That's weird. I guess I can. Fragment color F. It's lambda 1 times what? F1? Here I wish I could use LaTeX. Fragment color F is computed by this, where S1 is the data point being interpolated, and I and lambda I is the area, the triangle opposite the opposite the point, opposite the vertex in question. Kind of an awkward explanation. I think undeniably an awkward explanation, but the picture is just so much better. Oh, it's not the area. It's like the ratio of the area of that triangle to the total area of the triangle. The ratio of the area of the triangle opposite the vertex in question of the total, yeah. So that's accurate. It's not that understandable. Luckily, the picture is really understandable. Oh, if I turned off the controls, though. Cool. This is great. I'm making so much progress. So that's barycentric interpolation. Hierarchical model matrices. I guess I might as well finish this up. Meshes or empty coordinate spaces. With associated model matrices can be organized hierarchically to simplify positioning. I don't know for sure what I'd say about this, but like the visualization here that does this. Why would these get faster when I move the window? What in the world? Okay, anyway. This visualization pretty much tells you why you would want to organize model matrix hierarchically. Might be hard to switch the projection shaders to the default if they don't play nice with the other shaders Grant wrote. I don't know how long ago you wrote that, unfortunately. But that pretty much has to happen. Grant's shaders don't scale well. But, yeah. Yeah, it just pretty much has to happen. I mean, the advantage of the projection shaders, or one of the huge advantages, is that they're compatible with 3JS objects. And so you can just get a sphere just by reading it from 3JS, and other things, like a cone, cube, rectangular prisms, those sort of things, directly from that. The disadvantage is that you can't just transform between them, unfortunately. It's probably possible to rewrite the surface mobject so that you can transform between them, but do them in a way that's that has a concept of transformation matrices. That should be possible. Actually, I haven't even looked at the surface shader code. Maybe it's not too bad. Oh yeah, it's pretty bad. Wait, let me see. This doesn't seem that bad, the fragment shader. The thing about this is that these includes position point into frame, get GL position, don't know what this is, get rotated surface unit normal. But these are very non-standard functions that would be difficult to replicate. I think position point into frame is basically recreating a view matrix. Yeah, it literally is recreating a view matrix. It takes the camera center and the camera rotation. Spengali, thanks for following. But it takes the camera center and camera rotation and then transforms the point according to... first it translates, then it rotates it. So this is literally a by hand view matrix. The get GL position is probably something similar. Oh, and this is incorporating perspective. So this is a by hand projection matrix. Yeah, it takes the frame shape, the focal distance is fixed in frame, which is a concept that you can use with hierarchical model matrices. And it literally does the projection matrix calculations. What is PSF? Oh, perspective scale factor. So yeah. You can actually XYZ chords. Yeah, you can see it. If I were to rewrite this like this. Hold on. XYZ chords. This is applying a view matrix and then a projection matrix. That's what this is. The way you'd normally do this is basically like this. Only that would be a semicolon. But alas, that's not what it does. Maybe it'd be possible to translate it But at that point, you might as well rewrite it. Okay. Organize hierarchically to simplify positioning. Yeah, perfect. So after that, I think I could go straight to the logo. Which for this I just have to say, I probably just want to talk about modeling. To say either take models from somewhere else. I'll just say if a shape ever becomes complex, or if you ever need a complex shape, you should find a way to model it in a dedicated program. Because there's no way I would write out the triangle. Oh, not this. Wait, I don't want to write to movie. Stop! I can't stop it. It's developed a will of its own. Okay, great. Yeah, there's no way you'd write out triangle. Oh man, it's still doing the stupid weight. Whatever. Anyway, you wouldn't write out the triangle indices for something that complicated. This is what I wanted to do. And this is a decent showcase of... Maybe I could use this to illustrate an orthographic matrix versus a not orthographic matrix. Because if I made it a perspective matrix, I think this would look pretty bad. It doesn't look bad. Yeah, actually this looks pretty decent still. It just doesn't look exactly how... Oh, let me stop it rotating. Doesn't look exactly how the logo looks. Yeah, but it looks decent. Cool. And I think that's more or less all the notes I think I'm gonna need. Or all the notes that I want to have along with this. There's still a lot I have to do though. I'll probably want to talk some about geometries and materials, probably some about lighting. Oh yeah, and I do have to talk about... Oh, not only this, but I have to have an example with just working more with shaders. So probably... like something with a full screen quad, which there's already one written. Oh my gosh. Let's see if that works. Nope. Okay. And now I'm trapped. Good job, Manim devs. I'm a Manim dev, so I can say that. Maybe this will work. Okay, it did, but it's not the one I wanted. Was it inline? I think it's inline. Oh my gosh, that's not the one I wanted either. I want the one with the rotating colors. It must have been, it wasn't named? Named shader example. Shader, Manim chords. Yeah, that's not the one. Inline shader example. Model view matrix and projection matrix. Okay, so that's not the one. Simple inline full screen quad. Okay, it must have been this one. Line. Oh my gosh, that's not the one either. Is it inline full screen quad? Okay, this one for sure. I thought I ran this one before. Okay, that's the one. Although I guess it isn't taking in a variable resolution, I guess, because it's off-centered. No, it's taking config at pixel width. Anyway. On the to-dos for this, add variants about that. I'm also going to want to add a full screen quad example. So it's definitely a useful way of using shaders in Manim. What was the other thing I said? Geometries and materials, maybe. Have to fill out the vocabulary. Maybe lighting and normal matrices, I don't know. Great. Okay. Oh, and obviously fill out the vocabulary. And after I do those things, I think I'll be pretty much ready. Probably some more like, hands-on examples. Like at least one. Something where it's like, okay, make the code do this would probably be nice. Then if I went over all those, it'd probably be good to teach this. Great. Okay, but I'm not going to do that now. I could get into some of the web stuff I've been working on, but that'd be a pretty major context switch right now, so... It's been 2 hours, so I'll just raid someone. So thanks a ton for following. Or, hold on. Hi. Thanks a ton for watching. All the new people who came by, probably from the tweet or the announcement about the lesson. Feel free to follow. Definitely come in for the actual lesson in 2 weeks. But for now, I gotta find someone to raid. Which means I guess I actually have to go back to this screen. Oh, you know what I should also do one day? Is actually fill out my about section anyway. This person rated me before. He wrote a video game that I found really cool. But he won't even notice if I rated him, so. I rated this person once before. But I could just do it again. He's a pretty nice person. Or I could maybe do something smaller. Nah, just right. He's on that fang grind for sure. Is he really? Like, did you ask him, or do you just think he is? That's probably... Oh, he mentioned it when he rated. Okay. Let's see how long this person's been going. 2 hours is kind of long. It's longer than I would go. I don't know how you can do, like, an intensive task. Ah, he's been going pretty long, too. What about this person? Everyone's been going for 2 hours, dude. How? We could raid the VTuber. It's pretty late. Okay, I'm just gonna raid this person again. All right. Say hi. Be sure to follow if you haven't already, and I will talk to you guys in the next stream or Discord. All right, see you guys.